Welcome to this last guest lecture for MCT4046. Today we will have Pedro Pestana, who was born in Lisbon in 1975, and who has pursued an interdisciplinary career that always gravitates around sound and media. He has a PhD in computer music and is currently a Gulbenkian Professor of Interactive Sound Design at UCP in Porto. He has led the Research Center in Science and Technology of the Arts at UCP and taught extensively in several universities in Portugal. Working in intelligent systems applied to audio, he has helped found 2 software companies in Canada and worked as lead audio research and consultant in the audio software industry. As a sound engineer, he has worked with many prominent artists such as Teresa Salgueiro, Pedro Joya, Mario Laguinha, among others. He has worked in several media installations, drawing from his skills from physical computing, most recently with artist Bill Fontana. So give a warm welcome to Pedro Pestana. And we'll have what he has to say.
Thank you very much, Eigil, for the presentation. And I'm very, very happy to be here. I mean, to be virtually here. I'd be happier if I was with you. So I see you very, very tiny in my screen, and this might be a tough presentation. Just whenever you want, please do interrupt. If we see there's no lag, as apparently there is not, we can do this very, very interactively. But I have this kind of well scripted, so let me just give you an outline of what we'll be talking about. I'm keeping the technical side of things to a minimum, and I will try to give you a broad view of my perspective of what the integration between academia and marketplace from my particular niche in music technology could be. So I'll start with a brief introduction of my rather convoluted career path. And then for the first part, I'll try to give you some, let's say, career advice for early career researchers, because as I see you are just starting to choose your topics for your dissertation, I think I can have some useful ideas to give you. In the second part, so at 11, we'll get more specific, and I'll give you details on 3 projects I'm currently involved with, which are hybrid between research and marketplace innovation, and to some extent artistic intervention. So while these are very diverse endeavors, and only about 1.5 will tie to what probably are your interests in terms of sound art or sonification, mixing them together kind of serves to show how you can adapt the same sort of methodology to very diversified opportunities and outcomes. So a little bit about me. This is sort of an artistic depiction of my career. On the bottom part, you have the academic work, and on the top part, the industrial marketplace work. Now, I come from an audio engineering background, and I've worked professionally as an audio engineer / music producer for 15 years before coming to academia full-time. And I worked with a lot of high-profile artists, mostly in classical and acoustical worlds, but also jazz and sometimes pop and rock. And when doing this, my mindset was always that of a tinkerer or a hacker of sorts. And I had the feeling that sometimes I was known more because I would bring something new and wacky to the equation, rather than really because of my engineering prowess. So, for example, as I was frustrated by the iterative process of microphone placement, I developed a robot that could position a microphone with 4 degrees of freedom. So I was doing all my sessions placing microphones with robots, and I developed software for analysis of resonances in recording. I usually brought my own plugins to mixing sessions, and I actually built a multi-touch interface, big interface with lasers in the 90s, way before they were commercially available. So I became known as a sort of a scientist in a professional path that does a carefully balancing act between engineering, arts, and creativity. And in my sort of previous career, I got to found and build 3 recording studios. And I started juggling all this activity with teaching, which led me to the interest in actually a little bit late pursuing an academic career full time. I had done my pre-grad students in a different mindset, that of working outside academia and being in the industry full time. And as such, I think I had considered my choices quite carelessly and given little thought to anything other than following what seemed interesting to me, which at least is better in principle than following something that didn't seem interesting. But in hindsight, I think taking a road that led me to a significant pause between my MSc and PhD was, in my specific case, quite good, because when I came back, I actually had gained intuitively and unconsciously a lot of knowledge about how to organize a career, and that would be excruciatingly difficult if it had been otherwise. So, of course, I look back, and though having no regrets, I definitely wish I could have advanced earlier down a narrower path. And so I applaud and encourage all those who plan on doing it. And when the chance arose to do my PhD, and I was the first student to have a PhD in computer music in Portugal. So the idea of the chance really means to have a course available for my particular interests at that time. I was 100% sure about what I wanted to work on, and luck would have it, it was actually a topic that was so novel that it could be turned into a career that could plant the seeds for a full area, which now supports more and more researchers. Novelty is a very powerful tool, and regardless of how it is sometimes presented, our area is both young and full of novelty. So I think these are exciting times to be here. If you're doing something like chemistry, you have to be ruthless and tireless to be in the top 1% that can be hired for interesting positions. But if you're in a novel area, there's much more forgiveness to mistakes and oversights, which is great because there is much improved probability for making mistakes along this sort of career path, as I think I'll kind of show you. So I started working on what we called automatic mixing systems. This answered James Moore's call in his Audio for the New Millennium speech at the AES in 2000, in which he proclaimed the need for automated assistants to help us with the boring tasks and let us go on with the more creative tasks. So this is using what's called cross-adaptive processing, which is a digital signal processing technique where each of the parameters being processed in each of the inputs responds to a mapping that considers features from all inputs, and that will define the output. Our version was initially more of an attempt at artificially replicating what a human mixing engineer would do. This eventually modulated into the idea of intelligent audio systems, where cross-adaptive techniques would be extended so as to perform tasks that would be impossible to do manually. So the most trivial example of this would be something like demasking. In demasking, you have a process where you continuously equalize all the different tracks in a mix, and make them not overlap each other in terms of frequency bands, so they're always avoiding the spectral saliences in all other separate tracks. And a sound engineer will do this statically and in broad strokes and for the whole of a mix, but an algorithm can modulate it seamlessly through time and make it respond to different heuristics at the click of a button. So this was a stepping stone, and you can also imagine more radical solutions. For example, we developed something based on the notion that we are directionally deaf to narrow frequency bands. That is, it is proven that in terms of interaural intensity difference and interaural time difference, this will break down the sense of source position if you present users with only a very small slice of the spectrum. So we built this thing we call the dynamic spectral panner that splits all tracks in the mix into 512 different different frequency bands, and then pans each band separately so that they don't conflict with that band in different tracks. So you end up with each individual element being panned in a very strange situation where the mid frequencies could be left and the high frequencies could be right. But the result is a mix where everything seems to be in the center, but also seems to have width, which is clearer and less muddy. And that's something that was actually implemented in a famous mixing console for live shows, as there's this imperative need in live shows to have everything centered, but a lot can be gained by having it seem wide. So those were the sorts of problems we were tackling. At the time, there was only a handful of people that were working on that. Enrique Pérez Gonzalez, who is now at Midas, Stuart Mansbridge, who's at Subpac, and of course Josh Rees at Queen Mary, who was my supervisor for the PhD, and who should take all the credit for really starting this area. By the time I had finished, there were about 30 researchers working on this, and it had sparked much wider interest and also attracted the industry, which was at the same time fantastic and kind of bittersweet. I would say fantastic because it ended up being a valuable and enriching experience, but it was bittersweet because I have the feeling that whenever the industry attaches itself to something because of intellectual property issues, in terms of academic momentum, it gets a little bit smothered. So it's exactly because of this intellectual property rights that I need to gloss a little bit over the next part of the story. And I will just say that from the results of my PhD and others' work, there was this huge Canadian venture capital firm that invested in doing a startup that brought us along for the ride and is still going strong with more than 60 workers working on audio software. And it soon modulated into something they call automatic mastering with a strong machine learning backbone, and is not so rooted in cross-adaptive processing anymore. So in the meanwhile, our area still growing strong. I will advise you some books. In the meantime, there's this, you are very familiar with it, I would guess, this Dafex book, whose latest edition has a chapter written by Josh Rice, which is exactly on the idea of cross-adaptive processing and actually automatic mixing systems. So it's still not an area big enough to have its own book, but we're getting there. So as the industrial side of things moved along, I had the challenge of changing my research topics into a related but not competing path, while making it grow to accommodate grad student demands and attract additional attention. So I was fortunate enough to land a grant by Portugal's largest private foundation called Gulbenkian for a professorship that entailed work in interactive sound design driven by audio content analysis, with the rather novel premise of having interactive sound working as a social mediator of engagement between two human actors. So it's based on 3 case studies, always embedding a machine with some sort of intelligent machine hearing process that can make it either act as an antagonist to human interaction or as a helper to human interaction. This was actually a grant for 2 senior researchers during 4 years, and in that sense was optimal for the creation of a research group, a new research group over here. And the goal was to study the use of generative algorithms as facilitators or blockers of everyday interaction between humans. And there were, as I told you, 3 proposed case studies. The most obvious was the use of a generative musical system in musical improvisation between 2 performers, where the degree of entropy utilized in the generation process itself would bring about change, and thus a more radical departure from the canons of musical style, just influencing the human actors to change their own perspectives on improvisation. The system was originally fed with a large set of heuristic rules that contributed to its analysis of what's going on, and it would act upon MIDI data and not audio, and adapt to a given musical language in order to then depart from it. And as expected, I would say there's this sort of entropy sweet spot where diversity is welcome as a tool. So as performers reach ideas they actually did not know they did not know. And after that, there's the descent into chaos in terms of improvisation. And before that, there's just monotony and repetition. The second case study, which actually exceeded its initial plan and is still ongoing, related to the use of sound design of oral feedback in life support machines and EEG systems, and its use to healthcare professionals. And the process here is linked to the idea of sonification, or more properly, something like curated sonification, if you will, in that there is no one-to-one mapping of features to sonic parameters, but there's a layer of abstraction that builds upon some heuristics again. So the question of mediation here is how can you design sound that is informative to caregivers and at the same time soothing to those in need of care, so ambiguous, and there is a semantic encryption of sorts, which is an additional layer in treating this entropy aspect of generating sound. So however interesting this idea seemed to everybody involved, it proved to be much more difficult than anticipated to get things like proper clearances to do real-time work. So we did most of the experiments with relayed studies, with offline data and lab scenarios, which might not yield good real-world results, but it's still an ongoing process, and we're excited about that. The third case study was more of a blue sky project, and we considered it to be some more just anecdotal sort of project. But it actually yielded interesting results and a very big follow-up, which I'll be telling you about in the second part. The idea was to detect prosody in speech, specifically public speech, and our case study was with a classroom scenario. So the speech was the professor giving a class, and from that prosody, from that line, to automatically generate a soundtrack, which was not necessarily musical, but which amplified or at least underlined the emotion present in each sentence or unit of what was being said. So I'm happy that our work was recognized within our department as being a flagship example of how to organize research. And as a result, I was asked to manage the whole research center in Science and Technology of the Arts, which is called CITAR, and which harbors about 120 researchers in several stages of their careers and in many different areas of the arts. And while this was a very rewarding experience, it did manage to drive me away from research for about 2 years. So I was not doing research at the level I would like to, and it was great. It led me to a lot of networking opportunities, but it is now over and free again to do research. I've refocused and extended my prior pivot. So starting with intelligent systems for music production, and then intelligent systems for generative and interactive sound design. Now we're trying to follow the idea of using intelligent systems applied to sonic branding and immersive audio. So outside academia, we've landed a big project for brand refactoring of a major shopping mall chain. And brand refactoring here, I mean sonic brand refactoring, which I'll detail later. And in academia, it appears that we'll be joining a very big international player that's moving into the gaming industry for a procedural audio project, which involves automatic mixing as well as automatic generation. That's still very early stages, so I'm not really able to discuss anything about it. I still don't even know what it will involve, but it should be great. And hopefully that gave you a broad overview of what I've been doing. And the overall arch, I would say, is to embed audio systems with intelligence starting from the technical standpoint and then dangerously moving into the creative, so as to create more accessible tools to content producers and open up possibilities for a healthier sonic future, say. So this leads us to part 2 or part 1.5, early career choices. So as I said, I managed research at the Arts and Technology Center at our university for a couple of years. And that experience gave me some great insight into the pitfalls of a scientific career in this area and got me tuned into the importance of broadcasting some advice to young researchers. And you're right at a ripe point in starting your research career. So at this point, I really hope this was a bit of a leap for me. I really hope I don't sound preachy or paternalist in this part of the talk. And I know I'll be telling you things that will be mentioned by your advisors, and I'll give you information you'll find too obvious. And there are also some things I'll probably say which can't possibly kick in this early in your career. But once I knew I was scheduled to speak right before you're on track to deciding to making choices on your topics, I thought it would be an unpassable opportunity to give you some of my thoughts, and hopefully you'll find something useful in having an outside view on research. So all classes in methodology start with the importance of the research question for your dissertation and thesis or project or what have you. And while this emphasis is crucial and you won't be able to communicate your intentions properly if you don't have a specific and clear question, there's another aspect I really feel precedes it, but because it's so abstract, it really can't be taught in a methodology course. And that aspect is having a blue sky picture of what your research area could look like in the middle and long terms, and how your work will tie into that, having a sense of direction guided by a vision of sorts. So what do you know so far? What can you accomplish? What do you want to accomplish in very specific time frames, 5 years, 10 years, 20 years? Are you able to dig deep within yourself for a futuristic version of the world and align your interests with what you imagine will be a worthwhile vision of society in 20 years' time? So let me give you some examples. This is not necessarily what our area will look like in 20 years, but it's a possibility, and you can attach your ideas to this. So I think the first one, the bottom one, is not really a possibility, it's an inevitability. And I think not so far into the future, audio analytics should enter the Internet of Things world with extraordinary precision. As long as machines around us keep on listening, they'll be able to infer mood and emotion through cues such as footstep cadence or breathing intensity or specific verbal utterances, and they'll be able to understand the dynamics of your own environment, and by correlating with universally crowd-funded patterns, they'll be able to predict future happenings with startling accuracy. And that revolution is well underway, and I think that other than regulation, all that separates fact from fiction are technical things like microphone accuracy and dataset size. A little bit further off in time, immersive technologies will probably gain total recall like precision and completeness. And this is very unlikely to be tied with the current VR revolution of wearable headsets, and probably will depend in a more complete immersion, which I won't really speculate about. But whichever form it takes, the idea of limitless simulation has many implications for audio. I mean, all simulated audio should be procedural, and the apparent direction of sound sources needs to be externalized and made continuously distinguishable in space. Spatial rendering needs to be seamless and made seamless with multimodal cues, etc., etc. There's this book, the Oxford Handbook of Interactive Audio, and it has a very interesting and very unusual chapter by Damien Kastbauer, where he does exactly this prediction of a simulated future and its consequences for audio, and it reads very, very interestingly. So in another area, as healthcare advances are most likely making humans choose increasingly more radical bionic solutions, human hearing and machine hearing may converge enabling us with a whole new set of perceptual possibilities that depend upon augmentations of the audible spectrum. And here by augmentations, I don't exclusively or necessarily mean making the frequency span wider or the dynamic span wider, which may prove rather pointless, but things such as selective sonification of vital signs that gives us real-time monitoring of our own health conditions, or enhanced interpretation of prosodic cues that may reveal underlying emotions in others. Now, if any of these ideas inspire you or if they scare you, you might want to integrate them strongly into your prospective view of the world. And when reading audio technology research or devising your own, just relate to how it fits into that scenario. It may be that your construction of future worlds is not tainted by such an ambiguous technological inevitability, but a brighter perspective where we'll converge into a urban environment where soundscapes will be curated, noise pollution greatly eliminated, and sound health a priority. And that can very much be the end goal you strive to whenever you pitch your research against your view of reality. So I'm not really advocating that any of these too broad ideas should be a long-term research goal, but having a vision of how the future will be shaped in such broad strokes helps you assess the small steps your research will contribute towards that vision. And also that gives you a compelling story to tell others and to help you make people interested, engaged, and invested in what you have to propose or what you want to do. And that's actually the next point. Make your research meaningful and easy to communicate. Have a theme and find a relationship between the theme and your vision of the world around you. And go from theme to storyline. Always tell a story, and always be able to tell a story that explains where you're headed. Also, readily explain to yourself the motivation. Why you? Why are you working on that specific problem? How come your journey has led you so far? Where is your field of choice headed, and how do you relate to it? Do you see yourself working in it in a long time, and in what sort of capacity? If some of these questions do not have an apparent answer in your head, you should ask others, teachers, supervisors, colleagues. Be as open as possible, and remember to tell a story always. If you make it meaningful to others, it gets more compelling to yourself, and thus it gets more meaningful to others, and there's this virtuous cycle going on. So in choosing your theme, bear in mind to be problem-oriented and not technology-oriented or systems-oriented, which is something I really see a lot. Most people coming into research, they have just found a new technology and want to make it useful to their own goals, so they'll do something too technology-oriented. And this goes against the idea of motivation. When faced with a problem or given a problem, you should always dig deep into what motivates it. How did it come to be a problem to begin with? I can't really tell you how often I give a student a project and 2 months later, I find that while able to resolve the small problems that come to their path, the student still does not know why working on the topic is worthwhile and how it ties to audio research in general. So I try never to let this happen for something as big as a dissertation or thesis, but it's difficult to be inside the student's head. However, I really do like to make this point. I should say that this is something just to bear in mind and not really to be held as a mantra, because I'm deeply aware that it is as typical for young researchers not to be bothered by motivation as it is for senior researchers to be unable to grasp the significance of new technological or methodological advance. Max Planck, the physicist, famously said that science advances in deaths, and while a little bit grim, it actually is very perceptive of him. So there's something to be said about the importance of letting young researchers dream up strategies out of just unconscious intuition that stems from growing up in a world where novelty seems like obviousness. So here, an idea from not so scientific author Douglas Adams. He had this quote, which I find really interesting and prophetic, which is that if a technology exists when you are born, then it's a part of the world. You have no questions about it. If it appears when you're like ages 20 to 35, then it's a great opportunity, a place where you can make a career and make a living. And if it appears after 35, it's an abomination and it should not exist. So it's a little bit of an exaggeration, but it sort of makes sense. So now, when this big picture is clear in your head, dive into the specifics of the theme and enunciate the famous research question. Read it out loud, take it out for a spin, just test it around. Be wary of what is too large a slice of your big picture plan, and try to always work on subsets of ideas, small subsets of ideas that can end up as deliverable goals, be it a dissertation, an article, a working piece of software, a project, an installation, a patent, a report, whatever. As long as you can keep a realistic projection of your time frames, you should be in the clear in this aspect. And always overestimate the duration of a milestone. This allows you to have a scare factor buffer, which is really important, but also to be less obsessive about what you're doing and look at other people's work within your lab and within your research center. Offer your skills to senior researchers and collaborate on simple things, and be aware of what your colleagues are working on and strive to maintain a healthy group environment. And actually, I placed a little sidebar there. I've just been rereading Polya's very famous book, How to Solve It, which is actually a book on mathematics and mathematical problems, but I really feel it's still very current, and all his questions really adapt to nowadays. So make sure you do understand the problem and that you reason by analogy to other problems, specifically that when you're reading additional research that pertains to your topic, you can integrate it easily into the ideas you have now, and always break problems down into smaller problems and try to solve them incrementally. And that makes everything easier, whether it's mathematics or it's audio engineering or music technology. So now a bit of a word on publishing results, and we'll live in a publish or perish mind frame in universities, which is actually very dangerous, and many things have been written about its problems, and it is a heated subject in itself, but it's way outside our concerns here. And whatever the future may hold, at this point in time, I think it's essential that out of your master's work, there is at least one externally validated publication in the form of a scientific article. And actually, I'm not really sure your master's may force you to that. No?
No.
No. Okay, thanks. Sorry, I've been speaking for so long. Regardless of whether it's imperative or not, I really think it's important, and it's important to think about the thesis, the dissertation itself, as something that can be reduced down to one article, or that has a part that can be transformed into an article. And the point is, it's extremely essential that this is not an afterthought and is not driven exclusively by the need to publish itself. So I think one must think all our research in relationship to how it will look in articles, and be extra careful to make it interesting, to make the writing interesting, with careful balance between assuming a knowledgeable reader and making it something press friendly. So at this point, I'm guessing some of you will be wondering what makes a publication worthwhile, and you may be insecure about the value of your ideas or your writing style. And your advisor will have a big say in how the writing will shape out, and will ultimately make sure yours is a respectful contribution. So I would say there's nothing to worry about deeply, but there are some things you can do to hone your skills and to improve your capabilities. So first and foremost, don't neglect the idea that you have innate skills in pattern recognition. So much as more than half of what we do when learning music is made by simply listening to what others have done. There is a great deal of insight to be had simply reading articles by your peers and seniors. And seniors, sometimes people don't think about this, but make a point of knowing the published work of your professors. How do their articles read? How are they organized? Are they accessible? What's the motivation behind them? Can you see the steps that are building up to a solution? Can you categorize article type by methodology? Can you at least group them together in what relates to structure, form, or topic? Can you start to really be embedded inside the article's mind frame? Very importantly, can you see a follow-up? Is there anything in the article where you're left with a question and an idea to pursue something? Could you write something in your area of interest that follows in the footsteps and in the skeleton of the article you are now reading? So consider it to be a template. Does it relate to your own ideas and to your own work? So, as I said, your advisor will have a fundamental role in the success of your next year, and there are two aspects to avoid dearly when choosing the theme. Choosing a proposal that's outside the supervisor's area of comfort is very, very dangerous, and blindly accepting a proposal from your supervisor that you can't relate to is also very much perilous. So depending on your supervisor's plan and the synergy between you, I think it's likely that you'll end up with one of the following situations, and that will likely indicate how you should proceed in terms of publication. So number one, your supervisor is working at a new area that ties to a different topic of research, or is a novel but disparate extension of a previous topic of research he or she was working on. And here I think a survey paper may be in order. Survey papers usually are best left to leaders in the field, but if the area's extension is manageable, and if it is a novel topic, then this can be included into a master's project. It's a little bit dangerous and too much work, but it can yield excellent results, and in 5 years' time, your article can have top citations. Second hypothesis, you end up doing a hands-on project that is tangible and technical, resulting in a system or a process. Here you should think about a strong validation methodology that may link to quality or usability of your system or process. If it's a novel enough project, consider a patent. These are usually scary, but are very rewarding. Number three, you're doing something creative or artistic. Your main goal is performance or presentation. So here I would say, first aspect, could this be framed as first-person arts-based research? Or alternatively, is there a side problem that can be made objective and lead you to the paths in type 1 and type 2? Finally, number four, you get to solve a specific and well-bounded problem that is part of a larger research project. In this case, the article probably writes itself. There's a lot of inspiration in the literature used up to think up the project, and you just have to understand how your results frame into what has previously been done. And this is sort of a typical scenario. I don't know how things are organized in your masters, but usually there's this big divide between the idea that in hard sciences, students are handed down themes, and in the arts, students are very free to choose themes. I think the sweet spot should be in the middle. So remember, this might be a little bit of a scary prospect, but remember that the subjects that make your articles are things that will give you a fighting chance for your future career, and what you'll write will in the future reflect how you'll be seen by a very broad community. Academic positions typically open up with strong emphasis on publication, and even though our area usually is framed very generically, like if you're going into academia, you'll be trying out for an assistant professor in music technology position, for instance. Then the call is usually very narrow and specific in terms of subtopics. It will ask for computational auditory scene analysis or network music or something like that. So some of these subtopics will be way beyond the grasp of your chosen path, but it's good to have a balance between expertise in your main topic and bridging into diversified research, or there are occasions where you'll face exclusion on the grounds of not having published track record in an area where you may actually have a lot of experience on in either teaching or development. If you set your sights on industrial or marketplace development, then look carefully at what is being asked. Start keeping an eye out for job offers in both worlds, regardless of whether you are able to accept them. There are a lot of mailing lists that do a great job of broadcasting this. Signing for the Izmir list, for instance, is a must, as is the SMC network, or even the auditory list, which is a little bit off topic, but very, very active. I would say you should make yourself proficient in a couple of computer languages and more likely in machine learning approaches, as these seem to be a must for most of what's going on in our area for the next few decades. I would strongly suggest putting something like Python in your tool belt, if not already. I think it's part of your master's. And maybe something like C++, and to gently look at frameworks such as Keras and TensorFlow, but machine learning toolkits change very fast, and I would say you'll need to readapt several times before they become useful to you. So the present time is one of the many linchpins in your career, and I think you should give some careful consideration into how you see it shaping out. Again, a sense of direction is very, very, very important, not only to yourself, but in order to make your advisor trust you, in order to make juries believe that you're headed somewhere, in order to have project funders accept to finance you, and in order to have prospective hirers give you a chance, either in academia or in industry. You should always be able to tell a compelling story and make yourself believable in order to negotiate when leverage is maximal, which is usually in the beginning when choosing a theme, when getting funded, when getting hired, etc., etc., etc. If you're academically minded, look for the possibility of your research path generating a larger body of work, larger than you can possibly take on during a lifetime. And that allows you to build up a group of like-minded people working on your theme. If you want to go to market, focus on your ideas, their applicability, and always check whether they easily excite others, particularly in environments where you're not among like-minded individuals. Also, make your ideas modular and not too big so that they can potentially be outsourced and can yield results that you can show. And I think that's mostly what I had to say in this part. So, right, 45 minutes long, and I will stop now and wait for your questions. I hope this wasn't completely off topic for you, that it makes some sense.
Yeah.
Well.
I have a question. You mentioned some challenges you face yourself with the industry. I wonder if you can say something more about kind of the potential conflicts between having more market-oriented research or more open academic research.
Well, I mean, when you go to industry, either you are, if it's the software industry, I mean, either you are lucky and you're given a consultant agreement where there is not too much in the balance, so you're able to not sign an intellectual property deal, and you aren't given access to all of the source code the company has, so you're just going in to specific projects, specific areas, and try to fit into specific solutions, then it works great. It's not a problem. But if you're doing something that's more long term, and if you really tie down to all the software development part, then if you're working in a novel area, companies will definitely want you to sign non-disclosure agreements that prevent you from publishing, some non-competing agreements that will prevent you from doing anything related to that specific industry outside of that bound contract. And things get a little bit complicated in terms of your freedom. So I think I hinted at that idea that immediately after I joined the company, I was forced to go into a different research topic, and we really fought hard on the specifics of what I could and could not do. So what were the words I could not use again when seeing what my research direction is. Used again for a period of 5 years, but the period of 5 years in academia is absolutely gigantic. So that's sort of complicated. Then on the other hand, I hope I'm not going into a very dangerous field here, but universities take these things in different from different lights, and arts-based universities usually don't really care about what you do in terms of intellectual property. So it's kind of easy to sign a deal. You're doing things by yourself with a company. Engineering universities or engineering-minded universities will have a lot of regulation in place to what you can do with your theme after you stop and go to industry. So there you'll have a threefold negotiation with the company, yourself, and the university. So it might get a little bit more tricky.
All right, thanks. Any more questions? Are there any questions in Oslo?
Hi.
Hi.
I have a question. Well, this is a 2-year, our program here is a 2-year master program.
Mm-hmm.
So I'm just wondering about worrying about the read that you had there before. How focused and zoomed do we need to be to solve what kind of what size of a problem to have a successful master thesis or
Well, I think that broadly, and this happens internationally, you get this general idea that when you're doing a PhD, you're supposed to solve a novel problem. When you're doing an MSc or an MA, you're supposed to become a master in the field, an expert in the field. So the problem you're solving can be a little bit removed from novelty. Though I'm wary of saying this, because I would advise to work on a problem, because as I said, you should get published from, in my perspective, of course, you should get published from the point you're doing your MSc work. Then you should be working on some sort of novel and focused, restricted problem. It's quite hard to give specific advice there, because it will very much depend, as I said, on the interaction between your interests and your supervisor's interests. And you really can't go outside that. I would say it's more dangerous to have a blue sky idea and be really, really dogmatic about that than to work on something that's not so novel and that's just more run-of-the-mill. For instance, I had a first-year MSc student this year who came up to me with the idea because he knew we were working on EEG technologies. He wanted to do a very, very futuristic blue sky project where I kind of thought that his main goals would be to have a system where you'd think up sound design and the sound design would appear on the computer. And that's just, I think that's a 30-year project. That's not something you can do on an MSc. So for sure, have some understanding that you can solve it within the time frame of 1 year. And be focused enough. I mean, you want to be focused in an area. You don't want to be focused in a very tiny subset of an area, which is usually what a PhD student will want to do. So there's a sort of intermediate sweet spot over there. If I was showing books, and I will be showing more books, I would say, generally speaking, a book will give you an indication of an area that's consolidated and where people can be experts at. Whereas a research article, there's a huge gamut of different possibilities for research articles, and there is bad research out there. So this is not always also something that always happens, but a research article will constitute something novel. So if you're working from the perspective of an article you read, probably you're doing something that is a little bit too focused. If you're trying to follow up on it, then it might be just too focused for what an MSc is supposed to be doing. If you're working from the perspective of a book and you'll master a book and then will be able to contribute a little bit more along those lines, then probably you're in the sweet spot.
Thank you.
Yep.
You said that audio analytics in Internet of Things is inevitable. What about privacy and like GDPR and ethics? What do you think about that? Like, will that stand in the way? Anyway.
Oh yeah, for sure. That's the real problem at this point. I think that if you look at it globally, it's very unregulated. So to some extent, you could do mostly anything, but you'll get into problems in 2-3 years' time. But people will place safeguards on how privacy can be sustained. For instance, we worked with a company here in Lisbon that's doing Internet of Things microphones for placing in those Wi-Fi trees in public spaces. And the microphones themselves, they are microphones. They work with a diaphragm, but nothing outputs the microphone digitally that is not just semantic analysis. So you have no access to what anybody said during the period the microphone was on. You just have tags that mark whether a dog barked or people were having a fight or whatever. So I think privacy concerns will move into that area of a layer of semantics where you won't have access to all the data. You'll have access just to the data that can be disclosed and be made available. So yeah, we could have this conversation on many levels. It very much depends on what your worldview is. But I would also say, and it's interesting to be talking to people who grew up on the internet, right? Probably privacy won't be in 20 years' time what we considered privacy to be 20 years ago. I think probably right now it already is not. And people will start growing up less concerned about privacy. I know this is a strange and dangerous idea, but you inevitably, as you grow up, you inevitably share things you regret. And nowadays, sharing, we came to the conclusion that sharing is undeletable. So I think we will have, as a species, to refocus what we mean about privacy itself. But that's another very philosophical approach. So to answer your question properly, yes, privacy will be a big concern in how audio analytics will shape out. And at this point, I'm actually deeply concerned about technologies that are entering the marketplace and the safeguards that are not in place.
We should probably have a quick break. We should then reconvene at 11 for the second part.
Yeah. So should we start?
Yes.
Okay. So in my introduction, I promised I would tie together 3 very specific hands-on projects in different areas by placing them within the same methodological framework. And that methodological framework appears in our community because we're right in the intersection between arts and sciences. And that's a very unique place to be, where we have to make sense of the subjective. And making sense of the subjective is not too easy to do. And we really need to bridge this gap. And I would say that regardless of how you look at the crossroads themselves, we're at a place where, funnily enough, domain knowledge is in the hands of practitioners. So if we're looking at mixing, for instance, which was my first endeavor, people really know how to mix aren't scientists writing about mixing. They're practitioners doing the mixing. Usually, though music has entered academia very, very proficiently in musical aspects, power is also in the hands of practitioners, and particularly expert practitioners, and they have all this understanding, and usually there are 3 proven and tested ideas of getting information out of those who know it and making it more scientific, if you will, if information is out there in the real world. So the idea of knowledge engineering, it's a strategy that comes out of the software development industry about 40 or 50 years ago, where programmers would have no idea of the real world necessities of expert users when these were in the field where there's very hermetic or deep knowledge. And they developed this idea of knowledge acquisition, the process of gathering expert knowledge and capturing it in the form of rules and ontologies through observation and structured interviews. And more recently, it linked with artificial intelligence to refer to the rule acquisition strategy that can inform algorithms where some heuristic sort of knowledge is important. Grounded theory is a social sciences methodology that has fallen out of use for about 20 or 30 years, but it's interesting, and it involves the construction of theories through methodological and incremental gathering and analysis of data. So you start from a question or a preliminary collection of data, and then information is tagged with codes and further explored until you have a theoretical framework constructed. And it is an interesting strategy for knowing information that we still don't know we don't know. I very much use this sentence to try and know what you don't know you don't know. And as such, it can inform the first steps of knowledge engineering, which would necessitate a more structured approach and more data. And finally, machine learning is a big buzzword these days, and it needs no introduction. And in this scenario, it is something that I would say can be used to browse large data of practitioner or expert activity and to extract useful and reproducible patterns. So the first project is the actual construction of an automatic mixing system, the earlier academic one, pre-industry I had. And when I told you that this was my PhD work, I did not tell you the whole story. So initially, what I did want to do was to build a proof of concept system that could take in an arbitrary number of inputs, musical inputs, and produce a viable mix. And while we did do that, we had a couple of different case studies The bigger part of the work, and that which actually made my thesis stand out, was that we had to have a rationale for assuming the heuristics that would be necessary for a system such as this to work. So the premise of having a system that would mimic human mixing engineers, which was our starting point, and it diverged from that. But that premise made us question the way mixing engineers actually mix. And being in the profession myself, I had very strong ideas that were not accurate in the literature, and the literature was itself more technical and operational. So no systematic study had been done about the process of mixing, which means it's a right field for knowledge engineering and a diversified set of methodological tools, which I've been using ever since in a lot of projects I've worked in. Of course, with different perspectives, but it ends up being the same. So if you think about the vast wealth of information that's available to extract and that can give us hints as to how to understand the mixing process, you may come up with a list such as this one. So number one, analysis of commercial mixes. Every song that has been published underwent a mixing process. So while it's not reversible at this point, at least in the sense of understanding every piece of signal processing, it does yield itself to analysis and specific confirmation of some hypotheses you might have. For instance, are the low-end frequencies always panned in the center in a mix? Well, just low-pass filter a number of mixes and analyze the coherence between left and right side of the spectrum, and you'll get an answer if the number of mixes is proper. But there is a preliminary problem, though. Your choice of mixes may be poor and actually constitute an example of what bad mixing is. So we had to do something about what we chose, and actually chose to work with all the songs that had been #1 hit singles in the UK and the US from 1950 to 2010, which had the additional advantage of being long enough to allow us for the spotting of specific trends. And you may argue whether commercial success really means musical quality, but it's more difficult to argue that with commercial success come large recording budgets, and typically that means working with experts on top of their careers. So we think it works as a methodology. So you can have the system do large data mining chores like I mentioned previously, but you can also perform some subjective analysis where signal processing methods themselves will not bear results. For instance, to try and understand the loudness placement of a vocal in a mix, you can very well, there's no hard and fast rule to do that with signal processing. So you could do it subjectively by asking subjects or experts to lower the volume until you just can hear the voice, and then use a probe system to test the volume of the voice against that. Now, an extension of this methodology, and that's #2, would be to use specific cases where you have access to unprocessed multi-track versions, which is not so easy, and analyze them against the final mix. And while this is informative for some aspects like general balance or the amount of artificial reverberation used, it is fraught with perils, starting with the problem of quality that was mentioned earlier. But in this case, you don't have that many multi-tracks laying around, so it's difficult to make criteria for choosing them. But because the final versions are not only mixed but also mastered, so you have to try to disentangle what's what. And also you don't really have a steady and fast methodology for understanding all the signal processing that was done just from the final mix, though we're doing some advances towards that. We did, however, use this strategy, and we did collect a huge amount of multitracks, which are now expanded and being curated by Brecht de Man at Birmingham City University. A quick mention about a possibility that is really rare is to have access to a session where you have the multitracks and you have the final mix, and you can just cut all the processing off and understand everything that was being done. We didn't get more than 5 of these, so we actually never use them unless we're tying them together with a different methodology I'll tell you about in a little bit. So number 3, interviewing experts. And here we must choose the criteria for the term expert carefully. And in our case, we follow the idea of commercial success. So an expert would be someone who had published, who had worked on a mix that later on went to become a #1 single album. Between shows and conventions and private Skype conversations, we managed to talk to close to 100 engineers that would fit the bill. And through an increasingly structured approach to interviews tied with grounded theory, we tried to extract said information we did not know, we still did not know. So number 4, questionnaires. After doing interviews, you can make subjective material a little bit more objective by having something statistically tractable like a questionnaire. And once we had a very specific hypothesis, we could ask a large number of experts and treat results as objective as statistics will allow us to. So if you have 95% of interviewees that are positioning the kick drum in the center or always are EQing 110 hertz out of the acoustic guitar, then that would be a strong indication of a rule to model there. Then working with experts, continuing the work with experts, number 5, we have the idea of recruiting experts for mixing sessions, where a machine learning mixing interface was built, and the mixer's actions could be analyzed in real time, which is extraordinarily important to understand the iterative parts of mixing, which can't be explained by results alone. So we were able to figure out decisions related to demasking, how engineers would EQ as a function of panning decisions, or how they would pan according to EQ decisions. The only downside to this approach, this could be most of the work, but it's very, very time consuming and depends on the goodwill of experts and on the idea that they're performing as professionally or as expertly as they would in a commercial situation. So there are usually too few case studies to make it reliable science. And again, it contributes to a set of heuristics, which is the main bulk of what we were doing here. Number 6, you can eavesdrop on expert sessions, much like the traditional strategy of a master apprentice in music production. Sitting in on a session and analyzing the process from outside is very informative and another good example of the use of grounded theory. And finally, number 7, subjective testing with non-experts. There are some results that are easier to understand from the perspective of the listener than from the perspective of the mixer or producer. Choices related to compression, for instance, will very frequently see experts state one thing and then do the other, because while they personally prefer less compression, they also believe listeners prefer more. So we organized a battery of subjective tests that were mostly multi-stimulus tests, where participants would rate several versions of the same mix according to perceived quality, but also we had a method of adjustment tests where users were asked to set a parameter, or distinguishability tests to understand whether 2 different conditions were effectively listened to as being the same sort of result. So what sort of results can we get from this, and how do we use them? Let me give you a couple of examples. This first slide is an interesting idea. It's a plot of left-right coherence between the left and right channel of a mix of songs coming from 1950 to 2010. So you see the horizontal axis will be year of production. The depth axis will be frequency, with the low end on the back, on the part where you have a red emphasis. And the height will be coherence. And coherence is the normalized cross correlation between channels and gives you a measure of how similar they are. So if you look at it, you see on the first years a predominance of mono recording would make coherence big across the spectrum. And then you have that very fascinating period from 66 to 70, where nobody knew what to do with stereo and were experimenting, so coherence is really low. And then afterwards you have heavy coherence on the base frequencies, low coherence on middle and high frequencies. So that proves almost undeniably what I said about the idea that we pan the base frequencies centrally, and there are technical reasons for that also, but it is actually looking at real-world examples, it is true. But one very, very curious thing we could extract out of these results was what is seen in the plot on the right. The plot on the right is a superposition, an averaging of all the years. So you're seeing just the average between all songs from 50 to 2010, and the coherence vertically against frequency, just in the middle frequencies from about 500 to 2000 hertz. And you see this jagged approach, which is really weird until you superimpose the equal temperate scale, and you see that coherence is high between notes on the equal temperate scale. So what actually is happening here is this can only mean that we position melodic elements out of the center and noisy elements, think something like snare drum and kick drum, centrally. So the implications for a mapping process of an intelligent panning system here are obviously you just position elements with a low spectral centroid centrally, and you position elements which have something like a high zero crossing rate or something that will give an indication of their noisiness laterally, centrally as well. This second plot shows the ratio between left channel RMS energy and right channel RMS energy. The two horizontal lines in the middle give 1 dB variation. So this is the point where left and right are almost the same from the standpoint of energy. And if you see all, so the horizontal scale is year of production. Actually, it's song number, but it reflects year of production. So after about 1980, you see that all songs will be within this very, very, very tight range. No underlying, no outliers over there. And this means there's an energetic balance between left and right, and it would imply a process where a decision to pan an element to one side would implicate panning an equally energetic element to the other side. Or simply, it would mean if you do panning decisions, then just do them symmetrically. Now, this is a more curious result than actually a useful one. It was obtained through subjective testing. So 40 subjects, 40 participants, choosing quality of different conditions that were related to peak limiting, compression, and additional strategies for having louder volume. And here the conditions are, if you go, A is a condition where nothing is compressed. B is a condition where we use the transparent process called crest optimization, and then allowed the increase in volume to be heard by the subject. So subjects would rate that higher in quality, and that's just, in our opinion, and in previous literature, there's confirmation that, well, people will just rate higher in quality stimuli that are more energetic, that are louder. So louder is better in this aspect. And the other conditions are all loudness normalized. So they are normalized to sound as loud as the first condition, and they are respectively crest optimization, 5 dB peak limiting, 10 dB peak limiting, and compression done in a specific way. And you can see these plots with overlapping confidence bands tell you that people really can't distinguish between or aren't rating them differently. But there's a curious question there, which is if you see conditions D and E, they have much higher confidence bands. So that means more variance in responses. And we were looking at individual responses to try to understand the source of this variance. And it turns out there was this beta 1/2 distribution where you have polarization. Some people are saying it's really good and some people are saying it's really bad. And if you try to understand the people who are saying that this is really good, these are people aged 20 or less, whereas people who are saying this is really bad are people aged 25 or more. So this ties very much with what music you're used to hearing, and to the idea that most music produced for the last 20 years has been heavily peak limited. So people are picking on that and are doing subjective choices out of their own habituation. So it seems like a small result, but we were later able to use it when targeting music that was typically consumed by bracketed age groups. So hopefully this gave you an introductory idea of the thought process and methodology behind my first steps at an undertaking such as this one, the knowledge engineering part. And with this, let me show you a different project. First, I'll describe something that's a little bit left side of everything we've been talking about. This project comes from the artistic side of things. A couple of years ago, we started a partnership with a large museum in Lisbon, the Museum of Art, Architecture and Technology, MAT, which is owned by the Portuguese National Electric Company, and was built next to the first power plant in Lisbon, which is a power plant from the late 19th century. This power plant building is also part of the museological experience of the complex, and even if normally there is a split in which artistic projects go to the museum and the science exhibits go to the power plant. However, a Portuguese conceptual artist called Jawad was invited to make a custom exhibition for the museum, and he chose to do it exactly on the power plant, on the boiler room, which he wanted to transform into a huge music box. I'll just show you a little bit of the project. Sorry.
O típico projeto João Onofre seguiu uma linha de conversa que tivemos com a direção do museu e que tem como objetivo máximo gerar um protocolo em que teremos linhas de investigação e linhas de desenvolvimento conjuntas.
Então o João Onofre, que é o artista, idealizou aqui um projeto em que temos a Casa das Caldeiras, uma partitura que foi escrita por um percussionista que é o Miquel Bernat, e nós tratamos de que essa partitura fosse tocada por 16 braços robóticos. Toda a luz que é capturada por uma câmara influencia o andamento e o volume dessa partitura.
Okay, so this gives you a sense of space. He contacted us with this idea, and we devised a system of small actuators that acted as percussive arms with tiny drumsticks, and acted as were percutting against metallic surfaces. And we also had some more esoteric requirements for individual percussive robots, such as one that circled a rubber ball around a metallic surface, creating a rumbling sound, and some larger mallet robots with additional degrees of freedom that could hit larger elements. And this was all built with a custom microcontroller system that responded to MIDI messages. So at some point, the robotic orchestra could be played by a controller or sequenced from a DAW. And the rest of the idea revolved around energy sources, given that we were in a power plant. And because it is a beautiful riverside building, as you've seen, building facing the south, the artist wanted to bring in its more polluted past into a renewable energy feature and have the whole electronics be powered by solar panels, and to have the musical composition react to the sun's intensity and the position of the sun across the skyline. So we had no concept of what the mapping would be and how the composition would change, so there was some room for experimentation. Unfortunately, the largest and toughest concern with such a piece is its robustness. So it needs to be on 10 hours a day, every day for 6 months. So we need to put some safety nets in its own method of operation. So to this end, priorities were, as you see in this slide, number one, to have the robots be constructed by very resilient motors and test their wear and tear, make sure they are replaceable in a few minutes, and make sure they are hung in a flexible and reproducible manner. Two of these concerns were actually a big problem because hanging the motors was not absolutely free because we were clamping them to structures of great historical value. So some tough choices had to be made on the structures that were supporting the motors. And the robot arms were out of sight more than 14 meters in the air with places where boardwalk accessibility was quite scary. So this was a very, very tough project. And also the testing project, the process could not be done extensively as we did not have enough time to force a test procedure on the motors. So we had to rely a little bit on chance there. Number two, making the controller system connected to the internet over a secure connection so that it can be remotely monitored through a VNC system and that most crashes can be recovered without being physically present, and creating additional software that monitors the state of the computer and auto restarts the processing on crash. So a lot of other ideas that can also be useful, but the final three requirements, maybe, designing a system where catastrophic failure won't lead to an unbearable sound level or rhythmic repetition that may drive away visitors, designing a system where randomness is kept to a minimum, and designing a system where operation is simple to debug. This premises drove us to the decision of making things simple and have a very direct and simple mapping, which actually was in sync with the artist's original view. So the amount of light present would affect the tempo of a piece that was completely pre-written and sequenced, and the sun's position on the horizon, which was actually computed from time of day and not from the camera, would control some aspects of spatialization, given that many of the robots were actually amplified and there was a sound reinforcement system in place. So we brought in contemporary drummer Miquel Bernat, who composed a 30-minute piece for which he was using sample recordings of the actual hits, and he also did some live tweaks using percussive controllers. By now you'll have noticed that my description of the mapping process is not particularly interesting, even if it does address a specific conceptual and technical need. I made a point of describing this project in larger detail because I think it may possibly relate more to your needs and goals than the other projects I have to show, which are a little bit more speculative. But the relationship between this system and the rest of the talk is just now about to begin. Because this exhibition was a success and the setup experience was so interesting, we teamed up with the composer and his collective, which is called Drumming and based in Porto, in order to begin work on a project that would be a mobile version of the percussive robots concept. So Miquel, the percussionist, was excited by the possibility of having an extension of the techniques that could be used with their acoustic instruments beyond that which is humanly feasible, and which reminds me of my own premise with audio mixing and processing systems. And also he immediately started thinking about the hypothesis of having the system improvise and react in a manner that was more conducive to creativity and to new experiences, which very much ties to the aspect of social mediation we had tried before in the Gulbenkian project. On our side, we really wanted to experiment with more extensive mapping solutions that would stem from machine hearing systems in a context where we need to be looking at audio and not MIDI, and are bounded by the idea of rhythm and percussion, which at least in principle makes this a more tractable solution. We also wanted to extend the textural capabilities of the machines themselves, making them more organic and result in a better timbral characteristics by designing linkage systems that were more human-like. As an extension of this, we also wanted our robotic percussionists to be able to have a variety that's created by left-right alternation in drumming, and eventually to explore the possibilities of extending this variety to robots that have 3 or more separate mallets working in a variety of configurations. So this is still a project that's ongoing. We're doing a lot of experiments at this point. So there's nothing really to show, but I think you can imagine how it relates to the same sort of methodology I was telling you about later. So this time the experts are percussion masters, and the intelligent, sophisticated we want to extract is pretty much threefold. So first we want to know what are the rudiments that constitute the language of drumming. These are usually well-known heuristics, but we want to have them custom tailored to our specific group of percussionists. So we need to do extensive analysis to what sort of rhythmic patterns are created, in what sort of instruments, and this also includes the idea of how they are created from a mechanical and kinematical perspective. So beyond audio analysis and conversations, we are also looking at video and motion capture analysis. The second question is, what are the bases for improvisation and interaction that exist for this particular set of percussionists? So starting from simple motive identification and repetition, how sophisticated can the interaction get? Here's the aspect where the simplification to rhythm alone makes results more forgiving. And finally, what articulated mechanical gestures precede the hit itself? Are they invariant to speed? Do they depend upon orientation and surface? Again, this is a well-studied subject and there are methodologies in place, but we want to adapt our research to this particularly greatly accomplished players who make for a very fantastic laboratory and are a unique opportunity to have novel results. So all this looks to be the domain of machine learning with a strong emphasis in reinforcement learning techniques. But as I've been trying to advocate, there is a lot of space to have a knowledge engineering system and grounded theory stage that informs it. So we're setting up a strategy where we're having preliminary interviews with participants, trying to extract information that relates to points 2 and 3 above, and then have extensive solo and ensemble recording sessions that are interrupted by additional interviews. And an interesting point to make here is that the possibility to infer whether the intermediate interviews affect the drummer's process, that is, whether rationalizing and making creative or technical decisions more conscious will ultimately affect them by either rendering them mute or amplifying them. So that's an exciting idea in itself. It's sort of social mediation through consciousness. Now, for the final project I wanted to talk to you about, we move into a different domain of audio production, namely a more commercial one. I had mentioned the work where we tried to follow the prosody of a speaker's voice with a generative soundtrack. When we had the first prototypes of it working, chance would have it that I did a presentation where the method was tested, and we had someone in the audience who was a representative from a large conglomerate in Portugal that manages shopping malls. And I was talking about the importance of brand sounds and speculated about the idea of generative soundtracks that can be a game changer in settings such as shopping centers or hotels or spas, because you can have endless variety with an underlying set of restrictions and can make it respond to any stimulus or pattern that can be inferred by either individual or group behavior. And this caught the attention of the representative and launched a series of negotiations that finally came up with an ambitious project to build what, to my knowledge, will be the largest scale generative musical installation to date, done in 30 shopping malls across the country. So we actually do have some past experience in doing this sort of thing, but always with a very constrained scenario, which normally incorporates the following. There's just one room installations with normal room acoustics. We have done interactive projects for hotel lobbies or for individual stores. Usually these imply pre-composed musical stems and cues, which are created as layers and then cross-faded as response to stimuli. And eventually we use generative melodies on top of pre-composed layers or additional variation-inducing tricks without going full-on generative. Then the sensor input typically just comes from microphones and cameras, and it uses simple features and direct mapping to musical change. And finally, there's a lot of trial and error developing a piece that works as a cohesive whole. So you'll just be changing things around until it works. Now, many of you will be familiar with Brian Eno and Peter Chilva's Bloom, Enscape, and Reflection apps for iOS and Android. These previous works I was telling you about were similar to this in terms of process and the musical components and the general idea to how you approach generative elements, but added the spatial acoustic concern you get when working for a specific location, which is interesting, and also the freedom to have additional sensors to alter the sonic parameters. However, for this new project, we wanted to do something more ambitious in scope and that could yield research results. So one of the first ideas that sprang to mind was to use the detection of crowd patterns as an analysis tool that could be mapped to the sound aspects. Things like detecting the geometrical distribution of users and synthesize particle swarms that mimics it, or alter in-store musical content as a function of number of shoppers, using flow patterns as correlates for music intervention across spatial boundaries as people were walking around. And this was very exciting to the company itself, as the means were already in place, and our system could yield additional statistical information on how consumer behavior changes in the face of ambient changes. So this is live market research using sound, which is the only design element that mostly can be changed seamlessly. And there is already empirical evidence that, for example, shoppers will linger and buy more if the pace of in-store music is low, and they will tend to brisk through if the bits per minute are high. Our system will lend itself to large-scale analysis of patterns such as this. And this pitch landed us a big budget, and a big budget grants us a big opportunity, which again links to knowledge engineering. We could, when thinking up the algorithms for score generation, use the vast wealth of literature that offers established heuristics that have offered such interesting examples as David Cope's experiments in musical intelligence more than 2 decades ago. But this body of work usually comes from the analysis of one individual about his or her own thought process, or about literature that tries to produce rules according to a specific agenda. And granted, there is enough work on musical analysis and heuristics done from many angles, so we could very well perform some sort of meta-analysis and come to a conclusion. But from our end, it was just simply too good to pass on the opportunity of proposing knowledge engineering on composers, much as what we had done with sound engineers and percussionists before. So this is the road ahead. We're focusing solely on the creation of ambient soundtracks for the modulation of emotion, and we'll be conducting large-scale analysis, interviews, and machine learning exercises to extract best practices and rules of thumb that can be used in generative compositions. So this project will then be a combination of ambient sensing and machine learning and procedural audio. So I think I had finished the slides, right? So I was telling you about the project at the shopping malls, and we were using a combination of machine hearing and procedural audio alongside with a knowledge engineering approach that was again provided by an hypothesis to work with many specialist composers and to have a budget to do that. So again, the idea of extracting knowledge. And actually the last thing I'd like to talk to you about, and one of the questions in the intermission actually already hinted at that. I think some of you may have spotted the ethical elephant in the room. You may even have spotted several elephants in the room, which is, I've repeatedly used the terms extract knowledge and automated, and in today's technological turmoil, that sort of means replacing human work with machine work, and in the case of our area, replacing human talent with machine talent, or human creativity with computational creativity, which is something people are wary about. And I've got a couple of things to say about that. They may be a little bit far off, but first, for the apparently bleak part, I think it can be done, and it will be done. Machines can achieve of competence in technical and creative skills within the arts that will make computer production indistinguishable from human production in broad and average terms. And in places where stakes are high and access is boundless, we already start to see some very disturbing behavior. For example, in YouTube, you're getting a lot of content that is produced by algorithms, uploaded and marketed by bots, and the strangest part, viewed mostly by other bots. This is a dystopian approach to content that was 10 years ago in the hands of the media and 100 years ago in the hands of the arts. But this is not going away unless it is carefully regulated, and regulation at this specific aspect is getting more and more difficult by the minute. But however, I'm an optimist, and I try to frequently extrapolate from the past. And what we are looking into here are technological tools. And technology has always wreaked havoc in society. The end of painting was announced with the introduction of photography. The end of live music was announced with the introduction of magnetic recording. The end of photography was announced with the introduction of digital photography, and again with camera, cell phones. And all of the later have adapted and thrived. So some of them are actually better than ever. And the tools we're developing now will be integrated into a new paradigm of creativity, and will be used by both new and old practitioners in a way that will then be mined for more knowledge engineering. So I think we're building tools, and they'll create a new possibility for creativity. Because the main reason behind our need to produce creative content is the inbuilt, inextinguishable necessity to connect. And if we sense a disconnect, even if there are years of disruption, and the years we are going through now seem to me as years of disruption, we'll reinvent human expression using the new built tools. And if this all sounds very naive, let me maybe use a more convincing argument. I've been talking to practitioners for knowledge engineering for more than 10 years now. And these are people on top of their fields, on top of their professions. Some of them will also have the bleak view and share nothing out of the danger of being superseded by algorithms. Some of them may or may not have the bleak view and share nothing because they see sharing as a market opportunity and only will share if they're handsomely paid for it. But funnily enough, I found the vast majority will happily share and show a lot of interest for the results and the possibility to use them and break them creatively. So these are, after all, as myself and probably all of you, hackers and tinkerers at heart who want to keep on being creative with all the means at their disposal. So thank you for your attention, and I hope I was able to bring some sort of inspiration to your near future. And that's it for me.
All right. Thank you very much. Thank you for coming back. I don't know how much time we have for some Q&As now. I mean, if people have to leave, they have to leave. But how much time do you have, Pedro?
On my end, I'm completely okay. So
okay,
just as long as you're happy.
Maybe 10 or 15 minutes or so.
Okay.
Okay. Anyone have any questions? Go ahead. Suddenly the opening of 10 minutes.
Guys, the main question, I mean, the umbrella question is how specific can I be with my questions if I want to poke your brain about some of my interests with the thesis project?
Oh yeah, very specific. Please. Okay. That was sort of, I didn't tell you that on the first part, but that's sort of what I'm aiming at. If you want to bring me your ideas, that's great. I won't steal them.
I wouldn't worry about it. Yeah, so I guess my main problem is that I'm not really sure how much this field was evolved and developed, but I'm interested in trying to work with. I'm a saxophonist, a jazz saxophonist, an improviser, educated in jazz performance, and I'm wondering about finding some relations between machine learning and the melodic line
in harmony, improvisation, and the relation between harmony and melody when it comes to a player and machine learning.
Okay. What is your specific goal? What are you trying to achieve? What's your interest? So
what I heard from compositions that were made by machine learning algorithms is not something that musically attracts my ear. I'm not enjoying this kind of music, and it seems a bit weird for a musician that studied to listen to a machine that doesn't do it so well. So improving on that, I would guess, and then not really sure why doing that and not having more musicians that play music that is not connected to machine learning. So I mean, I'm in between, I guess.
Yeah, I guess the main motivation, something that's really important and I haven't brushed upon is that sometimes one of the main motivations behind this idea of having machines emulate human capabilities is to understand human capabilities better, right? So you're trying to understand how the processing of your perceptual and cognitive systems work when you make decisions. So if you tie into that, maybe you can find a more interesting motivation behind what you're trying to do. So that's just a broad stroke. Very specifically, I would say you're coming from an area where expressiveness is at maximum. Which means that when you're trying to look at machine learning algorithms that have been based initially on very simple examples where expressiveness is low, then it's almost inevitable that you'll find them to be uninteresting. So a point where definitely we need work on is expressiveness, which is an idea that is very, very elusive, right? How do you model that? How do you understand what it even means? Sorry, I should have. But it is a ripe topic because, as you said, it's not solved. If you find a problem, if you find that it doesn't work for you, then inevitably, if you keep poking on it, you will get to an idea of how it can be made better. It might be, it depends on your experience, but it might be a tough spot to get at because it's a very difficult problem to treat and you still have to know a lot of things before you reach the point where you can make a machine learning system that sounds really bad. So to make it sound really good is an ambitious effort, I would say. But it's a good, so then think about small steps that you can contribute to. So if I'm right and expressiveness is the problem, don't work on machine learning, work on the question of expressiveness.
Interesting. Yeah. That's a good input. Thank you.
A quick question. You mentioned some journals, I think. Do you see any emerging practices in publishing papers that might change the way research is done?
Emergent practices in publishing papers? You mean more, I mean, everybody is pushing the idea of open access and open science. So that definitely will be a big thing for the future. I think there are some changes at the very higher levels where inevitably things will change, but I'm not really sure if that's what interests you or not, because whether science is open or closed, that won't change our topics. It's really important, and I really am an advocate of open science, but I don't see exactly that having a correlation with the way you approach the methodological part of your work.
Perhaps more in the in terms of pacing, like how quickly you publish, probably also the length of a paper. If you wish to publish maybe results very quickly, that is something that's much easier now, but is maybe not as accepted.
It is, I guess there's some sort of sweet spot there, because you can only advance in science as much as you can understand previous research. And if research is done on a daily basis, it's very hard to keep up. So if we're forced to get into a situation where we need to publish based on results that were found yesterday, that will become a problem. And actually, that's not a possibility. So I think the sort of buffer of immediacy that we have now in access to information is adequate enough, and we can't make it faster because we won't be able to process it simply. You get in areas such as physics, everything is overnight. The practice is you publish your preprints, so as soon as you finish typing, it's published, at least on your university servers. In our areas, we can do things such as the Computer Music Journal, which has a wait list of 2 years. So the research you're doing now will be available in 2 years' time. That's a very large discrepancy, but I think somewhere in the middle is the ideal part. So we'll need to have journals that are more open, but still curated to a point where the information is well checked and useful. I sort of thought you were going into the direction of trends in terms of publishing. And that's a very dangerous question. For instance, I told you that I'm linked to the International Society of Music Information Retrieval, and I've been working as a reviewer for their conferences and now their journal for a lot of years. And there I can see something which more and more makes me cringe, which is a methodological approach that is a template. So most of the things you get to review are articles where you completely, you open the article and you know what will happen. It's always this. You have feature extraction, you have a very abstract proposal, you have feature extraction, machine learning, and less than optimally analyzed results. And it's getting a little bit problematic, and it goes towards my idea that you should think very much about what you're going to publish and about what your theme will do to your publishing chances, because otherwise you'll just end up looking at 20 different articles. You'll say, oh, I understand. This is the solution. This is how it's done. And then you produce one more boring and meaningless article. I think that was done to great lengths in psychology for about 30 years. And finally, it's kind of changing. But when psychology met statistics, people who were not really prepared for a statistical interpretation of things were immediately forced to just validate all their knowledge with a very superficial set of statistics. And it worked, to my mind, it worked terribly, and it was a 30-year loop, which is difficult to close. But so I hope that won't become a problem in terms of music production. And that's actually sort of what I hinted to as a problem in the idea that you have to publish or perish, because being forced to publish means you'll want to do it even if you don't need to do it. And if you don't need to do it, you'll probably be unaware of how to do it. And those are the steps that are really important to take in order to understand what your topic choice should be and what your publishing options should be. Does it make sense, Anna?
Yeah, and I have a question. So you are closing this seminar series on sonification and sound design. We have seen almost daily, on a daily basis, different approaches to sonification, Some of them are more kind of engineering type and more scientific. Others are more artistic, which doesn't mean they are not scientific, but we've seen like this range of different multiple approaches. You've been mentioning about engineering and the arts, and I would like to ask you, where do you then position yourself in terms of when addressing sonification in this range?
It's quite hard, and it relates to the small talk I was having with Oyvind in the intermission. I think you kind of understood that I come from a very technically minded, engineering minded background. So bear in mind that my presentation was not technical at all for what I'm used to. And maybe I think it's just in my nature to come across as very schematic and very, very organized. So my approach is always the approach of the engineering side of things. So when we did the sonification process for the EEG project, I was always the person who was selling validation. So more than caring about the mapping process and how what strategies we undertook until we got to a final solution that was adequate, I constantly wanted to validate that against the needs we had for the project. So on that case, it was let's have nurses and doctors come in and listen to this and see whether they can extract meaning. And if they can't extract meaning, then just probe them until we understand what's lacking in order for them to be able to extract meaning. But having said that, I think the methodology in terms of sonification lends itself very much to a creative, almost everything goes mindset, because if you start sonifying from a direct mapping of parameters, of features to parameters, then if you use my mindset and if you go and analyze it and try to make sense of it, you immediately start to see patterns and connections that can then go on a feedback loop to the process itself. And then you will say, well, I won't map features directly to parameters. I need some high-level concepts, and those will work for me, or something else. Does it make sense?
Yes, thank you.
I know we had the other day conversation with Anna, and I remember you were saying it's not about publish or perish anymore, it's dim or die. So how much value is there if you have to publish just to be out there? So is it that what you were kind of
Yeah, I was implying that there is no value. There's potentially no value. Yeah, if you don't really consider your research in relationship to your career, I think this is a very ambiguous point, and I can get in trouble for telling you no value, but unless you understand that it is valuable, then we are all contributing to a system that is perverse in nature. It just churning out papers because you have to isn't satisfactory. So it will only end up creating a system where too much information and too much useless information is at hand, and we have the strong risk of producing all branches of bad science just because people were publishing because they had to. That's definitely a problem. But having said that, there's a point where you have to publish, and there are very unfortunate points where you'll be evaluated by publishing, and all that matters is whether you have or not published. So that's also a problem. I won't sell you this as an elegant solution. It is a problem, but it's something we really have to face and try to make the best of. But here I would do a specifically caveat as well and say
that there are a lot of institutions which are now negatively penalizing you for publishing in places with no reputation or that are very dubious in nature. So one thing that is very dangerous about bad science is that there are a lot of individuals who are just doing journals that have no value, no peer review, nothing at all, or conferences where the only goal is to make money, and universities are looking at them as being a negative point in your career and not actually a positive point in your career. So you have to be extra careful again to validate your outputs.
Yeah, fits also to the time. I mean, with this overload on information, and it's on many different ends. So academia is not, it's not excluded from it, right?
Yeah, for sure.
Right. I think let's have one more.
Yeah.
Yeah.
So it's back to ethics and machine learning and your mixing project. So the question is, if machine learning systems learns the mediums or trends of mixings and applies them, won't you result in a very standardized pattern? And how is it possible to avoid a homogeneous mixes and results when using machine learning for creative processes such as editing music?
Okay, sorry. I'm not sure if I really understood all the depth of your question. Was it something like the machine learning processes will deliver results that are very, very self-similar and thus uninteresting?
Yes, basically that's the discussion at large.
Yeah, that's kind of true, and that's actually kind of, I think, helpful, because you have to, well, my concerns, I also come from a mixing background, so I'm not somebody who will openly tell you it will be great if we have full-blown automatic mixing systems. I think it will not be necessarily bad, because we will use them and then we'll instill them with additional layers of creativity, and the full-blown mixing systems will only take care of the technical aspects of things, which are sort of, as you said, boring and self-similar, and there's not too much going on there in terms of variety and creativity. And as that happens, the role of the mixing engineer will be less about worrying with optimization choices and more worrying about how can we defeat the process so that it sounds different to all the other processes. Because I think in sound engineering and in mixing, the artistic standpoint is exactly that. It should not be exactly the same to all previous recordings and all of last year's recordings, etc., etc., etc. So unless you're talking about something like classical recording, where you have to be very, very accurate and transparency is the goal, but I don't think mixing systems have too much to do with that. It's just a question of recording. In all other genres where mixing is available, you're absolutely right. The idea of automation will bring about conformity and homogeneity, but that's exactly the point that allows us to then work it for creativity.
Can you repeat the last sentence you said?
That is exactly the point that makes them good for us to work with them and to instill them with our inbred creativity.
All right. Thank you very much. Thanks everyone for staying a bit longer. And another round of applause for Pedro.